Hello students, welcome to the online classes of Kerala Public School. Our today topic is rational number of class 8th. This is part first. You will get two more parts for this chapter as a video lecture. In this chapter, we are going to learn about introduction of rational numbers. We are going to recall our number system which we have learned in the previous classes and some basic concepts. So let us start. Before starting rational numbers, I would like to recall number system in which we have learned natural numbers, whole numbers, integers, rational numbers. So without wasting time, let us explain what is natural numbers. As you know, all counting numbers are called natural numbers. As you can see that whatever we want to count, we always start from 1 and it goes to infinite. So natural numbers are those numbers who are starting from 1 and goes to infinity are called natural numbers. These are also called counting numbers. Now next one is whole number. In whole numbers we can say that the all natural numbers along with 0 are called whole numbers. As you can see, the set of natural numbers contain 1, 2, 3, 4, 5 up to infinity, and set of whole numbers, all natural numbers, you can see 1, 2, 3, 4, 5 but along with 0. These numbers are called whole numbers. You have also learned about the integers, so I will quickly recall this number. Integers, you can say that there are three types of integers. Which one? First one, positive integers, second, negative integers, and third is zero integer. Zero integer is signless. As you know, zero is a signless integer. So we can say there are three types of integers. Which one? Positive integers, negative integers, and zero integers, or we can say signless integer. Now next number is rational numbers. Now what is rational numbers? As you have learned about natural numbers, whole numbers, integers. So rational numbers, we can say every number which can be written in the form of p by q, where p and q both are integer and q does not equal to 0, where p and q both are integer and q does not equal to 0. Why we are saying that q must not equal to 0? Let me give you one example. Have we divided ever 1 by 0? Have we tried to divide 1 by 0? If in that case we are not able to divide 1 by 0, so therefore we may write undefined. Understood? So that's why we are saying that every numbers which can be written form of p by q, where p and q both are integers and q must not equal to 0, are called rational numbers. Now you may ask one thing, that whether 1 is a rational number or not, and I'll say yes, 1 is a rational number because 1 can be written as 1 by 1. Similarly, 2 can be written as 2 by 1, 3 can be written as 3 by 1, 4 can be written as 4 by 1. So in this way we can say that the all natural numbers are whole numbers. But if we talk about 4 by 3, let me check, this is a natural number or not? So our answer should be no, this is not a natural number because this is representing a fraction form. You got it? So we can say that every natural number is a rational number, but every rational number is not a natural number. Similarly, if we talk about whole numbers, as you can see that all natural numbers along with 0 are whole numbers, and we have also learned that all natural numbers are rational numbers, so we will discuss about 0 only. So if we write 0, 0 can be written as 0 by 1, because 1 is the multiplicity identity. So if we divide 0 by 1, we will get 0. So therefore we can say 0 is also a rational number, because 0 can be written in the form of p by q, where p and q both are integer. You can say 0 is also integer, 1 is also integer, and the second condition that q, here the value of q is equal to 1, which is not equal to 0. Got it? So we can say all conditions of rational numbers are satisfied. So therefore we can say that every whole number is a rational number, but every rational number is not a whole number. In the same way, if all positive numbers are rational numbers, so all negative numbers are also rational numbers. You can write that minus 4 can be written as minus 4 by 1, minus 3 can be written as minus 3 by 1, minus 2 can be written as minus 2 by 1. Got it? Why we are taking always denominator as 1? Because 1 is the multiplicative identity, so the value will be unchanged. Got it? So that's why we can say that these all natural numbers, all whole numbers, all integers are rational number, while every rational number is not natural number, every rational number is not integer, every rational number is not whole number. So now let us discuss about the representation of rational numbers on number line. In the previous classes, you have learned how to represent natural numbers, whole numbers, integers on number line. So here I have drawn a number line, and on which you can say these are positive integers which are representing right side of 0, and these are negative integers which are representing left side of 0, and 0 will be 0 integer which is signless. Got it? So our first part is we need to represent 4 on number line. So easily we can represent. You also know how to represent. In previous classes you have learned. So it will be on right side of 0. So simply we will count 4 distance from 0, and that should be equal to 1, 2, 3 and 4. So you can say that the plus 4 will be right side of 0. The next number is minus 3, and since it is negative, so it will be on left side of 0, because negative integers are always representing on left side of 0. So therefore we can say that minus 3 should be the 3 unit distance from the 0 on left side, so it should be here. Got it? The next terms is 0. 0, as you know, it is representing on the middle of minus infinitive and positive infinitive. Got it, everybody? So next one is 1 whole 2 by 3. This is actually a fraction form, so we can convert it into the improper form. 1 whole 2 by 3 can be written as actually 5 by 3. Got it? Which is a improper fraction. So always remember, the proper fraction which is in the form of rational numbers will be always lie between 0 to 1 if it is positive rational number, and if it is negative rational number, so it will lie between 0 to minus 1. Make sure I'm talking about the proper fractions, and do not take sign over here. Sign is just representing the condition that if it is negative, so it will be lie on left side, and if it is positive, then it will lie on right side of 0. You got it all? Now we need to represent that 1 whole 2 by 3, which is actually equal to 5 by 3. So you can say, since it is mixed fraction, so simply here we have 1 whole, so just count 0 to 1 distance in whole, and the 2 by 3, that is the proper fraction. Now just next distance from 1 to 2, divide it into 3 equal parts as I have divided. You can see over here 1, 2 and 3. Got it? And now we will take the second part, because we are going to represent 2 by 3. So you can say 1 whole 2 by 3 is representing by this point. You got it all? Let me repeat again. If we are going to represent a mixed fraction, or we can say a rational number which is a positive rational number, so definitely it should be the right side of 0. And since it is 1 whole 2 by 3, so you have to take the whole distance as we are given 1 from 0 to 1, which we have taken 0 to 1, and the just next distance which is 1 to 2, you have to divide it into 3 equal parts. 3 equal parts as I have divided, you can see in the figure, and you have to take second part. So this point is representing 1 whole 2 by 3. Got it? And the last part is, here we have 14 by 6. 14 by 6 actually a equivalent fraction, which I am going to explain after this. 14 by 6, if we are going to find its simplest form, so you can say there is a common factor 2 between them, and if we divide by 2, we got 7 by 3. 7 by 3, and 7 by 3, you can say this is also a improper fraction, so we need to convert this into a mixed fraction. So we can say 2 whole 1 by 3. You got it all? Similarly, now you can represent, since here we have 2 whole, so you have to count 2 positive distance. Since it is positive rational number, so you have to count 2 positive distance from 0, as we have 1 and 2. Thereafter, just next distance you need to divide it into 3 equal parts. As you can see, I have divided 1, 2, 3, and out of 3 you have to take its first part. So this point is representing 2 whole 1 by 3, which is actually equal to 7 by 3, and it's equal to equivalent rational number 14 by 6. You got it? Let us go to next. Let's see what is next. As I was saying, that I'm going to explain equivalent rational numbers. What is equivalent rational number? We can say the rational numbers which are equal in value. For example, as I given you one example, let me take another one. We have 10 by 12. You can see there is a common factor between 10 and 12, that is 2. So let me divide it. If I divide 10 by 2, I will get 5. If I divide 12 by 2, I will get 6. So we can say 5 by 6 and 10 by 12 are have the same value, because their simplest form are equal. So we can say that 10 by 12 is a equivalent rational numbers of 5 by 6. You got it all? Make sure the equal rational numbers with different sign cannot be equal. For example, 1 by 2 cannot be equal to minus 1 by 2, since it is positive rational number and it is negative rational numbers, so they cannot be equal. Now the next thing is multiplicative identity. As you have learned, one is the multiplicative identity. How we will define multiplicative identity? Is a number by which if we divide a number, we got the same number itself. For example, 2 by 3, if I divide by 1, and I'll get 2 by 3. So we can say 1 is the multiplicative identity, because after multiplying this number, we are getting the same number, same result. So we can say 1 is called the multiplicative identity. If I ask one thing, that I have a number 5 by 4, 5 by 4, and I would like to know that what is its multiplicative identity, so you have to mark question mark over here. But you know, if it multiplied by multiplicative identity by a number, so we will get the same number itself. So you can divide it, and by dividing you will get question mark, that is equal to 1. So we can say that is 1 is the multiplicative identity. Now the next, negative of a number. That is so simple. In general form, an integer a, we have a plus minus of a is equal to minus of a plus a is equal to 0. So a is the negative of minus a and minus a is the negative of a. It is also called additive inverse. For example, you can say 7 plus minus of 7 is equal to 0. That is so simple. If I ask what is the negative of 4, so simply you can say minus 4. If I ask what is the negative of minus 16, so you can check out minus of minus 16, and that is equal to plus 16. Got it? Also you can say that the sum of plus 16 and minus 16, that is equal to 0. Got it or not? So we can say that the plus 16 is the negative of minus 16 and minus 16 is the negative of plus 16, and also we can call them additive inverse. The next is reciprocal. What is reciprocal? If there are two numbers like a by b, which are rational numbers, and c by d, and if we multiply them, and after multiply them, if we got a multiplicative identity, that is 1, so we can say these both numbers, which one, a by b and c by d, are called reciprocal of each other. Got it? So you can learn this definition. If there are two rational numbers such that a by b multiplies c by d is equal to 1, where a by is the first rational number and c by d is the second rational number, then they are called reciprocal of each other. As you can see in example, 3 by 4 multiply 4 by 3 is equal to 1. So let me ask one thing, that what is the reciprocal of 3 by 4? You will